I'm Christopher Esplin, and I will be covering more Firebase again today. As usual, this time I'm going to cover querying data. There are only a handful of ways to query data with Firebase, so we should be able to cover them all pretty quickly in this video. Okay, what we're going to use, I may or may not use Axios, but I like it to run some HTTP requests, some REST requests, if you want to use the REST API and query via that. But the main thing we're going to use is the Node client, and that just takes Firebase. So npm install Firebase will get you the Firebase client for Node. This works exactly the same way in a web browser. So you can, the configuration, so Firebase initialize app here is a little bit different in a web browser. You don't use a service account, but in Node use a service account right there. Okay, database URL, then a ref. I'm just going to work off of query data. As you can see right here, I've got on the my right hand side, I've got a browser open with Quiver2 query data, a user's node. I've got a bunch of users in here. They're all from the Swappy API, the Star Wars API. So they're ordered. They've got names and heights. The heights are strings. The names are strings. The order is a number. And you can see, of course, I follow best practices here. I used push keys instead of any other key methodology. So there are all these keys, but look at how nicely these things sort. These push keys all sort by the order that I added them. So I added Luke Skywalker, then C-3PO, then R2-D2. So these guys all order really nicely in my viewer over here on the right. Okay. So we're going to run nodemon, and you're going to see what happens when I run this script right here with listening OnValue to the user's ref. Whoop. Enter down here. There we go. All right. So you'll notice when I listen OnValue, it returns the value returned into the snapshot is an object that represents, just a JSON object that represents this entire data structure of users. Any ordering here is purely coincidental at this point because JSON objects don't inherently have any order to them. Now, arrays have order, but we don't use arrays in Firebase. Firebase doesn't really recognize the concept of an array. It uses these collections with push keys. So when you listen to OnValue, you're not getting necessarily ordered data. You're getting just an object, and the keys are going to fall where they may. Now, the fact that they happen to be falling here in this ordered fashion is great, but I could never rely on that. Okay, so OnValue. There are a couple ways to listen to value. A lot of times, you're going to listen to value just once. So the Firebase SDK allows us to do that. Users ref.once value. It returns a promise. So we can get exactly the same data here by listening to on once. Now you can't. The other events don't work for this because only value can happen just once. Everything else happens, or all the other events you listen to, you'd expect them to happen multiple times, and so we need a callback system, not a promise system. So yeah, usersref.once value is the only string you can pass into .once at this point in time to get a nice promise interface for a single callback. Usually, you're expecting lots of callbacks. For instance, the second most common way to get data after OnValue is onChildAdded. Now this will get called once for every existing child record, and then as you add children, it'll get called again. Whereas OnValue will get called for every single change. It's called once initially, and then every time there's a change, it'll get called. Now if you use .once instead of .onValue, it only of course goes the one time. But let's do OnValue, and we'll just show you. So let's add a record over here. Hey, true. There we go. Hey, true. So because I've got hey, true down here now, it just fired the whole thing again. There was a value change. I mean, if I go through in here and I change hey to false, look, it runs again. It'll just keep going. Okay. If I delete it, look, it went again. Okay, so listening with the on instead of the once will listen to all value changes. So now let's go to child added again and just say, hey, child added. Okay. So this will fire once, an individual fire for every child. And this will actually respect order. This one's going to fire in order. It'll, by default, order by key. Now, if you really want to make sure it's ordering by key, don't trust the default. Actually say order by key. So you can say dot order by key like this. Check that out. Save that, run it again. It will definitely order by key in that case. Now I could also say order by child and pass in the order. Oh, there we go. Order by the child. Of course, it's the same order. But let's try order by height. Now this is a string, so it's going to order it. It's going to alphanumeric sort it as a number. But look at that. We get 150, 165, 167. So we can order by child as well. There's also order by value. It does not pass in a string. But I wonder what this does. It shouldn't really do anything. It's still order by key. Because this isn't a shallow list. So if the list were just a list of values, so just push keys and value, like whatever this key, and there wasn't anything below it besides just the key equaled. Like, okay, let's just set one up. Let's just say that all the keys look like this. Some push key value 50. If they were all just keys and values, then you could use order by value right here to order by the value, because you can't order by a child because there's no child. There's just the value. I don't use order by value very often because I'm not usually ordering. I don't really, in my day-to-day, use these sorts of really shallow lists. So I stick with order by child and order by key. Order by key being by far the most common, because push keys sort alphanumerically by time. So you kind of get them ordered by time, and that's typically how you want to order your data anyway. Now, if you want to pull it down some other way, great. Oh, yeah. Well, we'll cover this in a minute, but we'll cover some other use cases in which you'd want to use order by child instead of order by key. There's also order by priority, but no one uses priority anymore. Don't use priority. Just don't. Just trust me on this. Use order by child. Priority is an old concept that is going away. Okay, so there's child added, which fires once for every child, and value, the value event we've already covered, which fires once for every, as a single, it returns a full object, and then returns that full object every time there's any sort of change. There's also child removed. I mean, guess what this does? This will do exactly what you expect it to. So I can come over here, I can add a child. Hey, true. Nothing happens, of course. But when I remove it, there we go. There's also child changed. This is equally obvious. But just to make it super obvious to everybody involved, let's say we change this order now in this case. Woo! Change your order to 11, Obi-Wan. Now you're 11. We get the child that was changed. Okay? So child removed, the snap you get is the removed child. There's no point in just returning an empty snap. So they actually give you what was removed. That's useful. So you can find that snap and remove it from your data set. Oh, yeah, and in case there's any question, let's show you how the keys work. So it's now snap.key. Oh, whoa, what's... Woo. And let's move back to child added, because I don't want to keep changing things just for kicks. All right. On child added. So snap.key will give you the key. That's how you get the key. And if you want the value, of course, you do that. And if you want the ref, I don't want to print full refs because they're ugly objects. So we'll just print the toString, and it'll give you the toString. That'll tell you the string for the ref. Okay. So snap.ref, snap.key, and snap.val. Val's are the only one that's a function at this point. This is actually different from the old Firebase 2.1 and 2.0, 2. Whatever, 2.x. It was like key was a function and ref was a function to get them, but now only val is a function to get the value. The rest are just attributes. Okay, child, we've covered child value, child added, child changed, child removed. There's also a child moved. Child moved, but that only matters for priorities and for order changes. So unless you're doing a lot of fancy ordering, I wouldn't really worry about child moved. I'd never have actually used it. So yeah, child added is the best. Yeah, you can use a, so say var users you can use OnValue to say users equals snap.val, and this will keep, the nice thing about this method here is it'll just keep my memory in sync with Firebase. My local JavaScript memory, my object here, users will just stay in sync. So if I want to keep something small in sync, I use value. But OnValue doesn't scale very well. Like, yeah, I can get 10 records. That's no big deal, and just call it all the time when things change. If it's not changing very much, who cares? But in reality, if you want your app to scale, you want to sort of think, okay, how is this going to change a lot? What if it gets big? What if I have 1 million records? I can't be calling OnValue and pulling down 1 million records all the time. That's just insane. And it will slow your Firebase down. I mean, Firebase has got great performance, but only if you respect it. If you just hash your Firebase instance, calling .onValue constantly for all these changes and huge lists, your Firebase is really going to slow to a crawl. So don't do that. Just use OnValue for small little things and use child added for the good stuff. Here, check this out. All right, so child added. I can say users equals an array, and check this out. Users.push. I can just push on, and look at that. Child, come on. So this will also keep it in order. Now, if I want to listen to removals and changes and all that, I'm going to have to listen as well to have two more listeners, one for child removed and one for child changed. But this will scale much better. And check this out. Order by key. Because I have explicitly said order by key, now I can use advanced query methods to make this much more efficient. So order by key, we got order by key, order by child, order by value. I'm ordering by key in this case, and I'm going to run what's called a well, let's see, limit to last. There we go. Limit to last one. I just want the last one. All right. So limit to first and limit to last. In this case, this will just give me Obi-Wan Kenobi, which is the last one, as ordered by the keys. If I limit to first, If I limit to first, I get the first one. Okay. Now, limiting to last is probably the most useful way to do this because we add things usually to the ends of lists. So limit to last, this will give you one record, the first record. It won't give you all of them, just the first record. But then every time I add anything, hey, you guys, oh look, that'll go through as well. So hey, you guys, or you guys, okay, obviously I'm still using this users push thing, so it's ugly as sin. Let's just snap.val. Let's just throw the snap.val out here. So it just gives us the last one, and then second new last one. Hey. Okay. So it'll then just continue to read out anything that's added to the list. This is really great for populating a list and then just sort of adding to the list as you go, like for a chat app. And if you just want to listen to changes, you don't want to listen to that initial payload with limit to last one, you can just ignore the very first time it gets called, have a flag that's like, has been called once. Oh yeah, if it hasn't been called once, ignore that first call, and then from then on out, you can act on that. That'll let you quickly just listen to additions to your data set. Okay, child added. limit to last, limit to first. How about limit to last, but let's start at, okay, let's start at, we now have .start at and .end at, but I am not going to try to take order by child. I'm not going to try to type in all of these keys. So I'm going to order by child order, limit to last, start at 3. All right, so in this case, I decided to start at 3. So it'll just give me 3, but look at this, more false. I kind of hamstrung myself with this one because I'm starting at 3 and limiting to the last one. So by starting at 3 and limiting to the last one, I'm not going to be able to catch these new guys I'm adding to the bottom. So it's kind of a pointless thing to do. Now let's try to end at. What happens when I end at 3? Okay, same thing. Another one. Yep. Okay, that one also, you see, it didn't go. So by using a start at or an end at, I can sort of jack up the list system I had before. Let's end at 11 this time, because I changed 10 to 11 right there. Oh, okay. Now we're jacked up. Now I got to get rid of these, because they don't even have children. Come on. Almost there. Almost there. Okay, back to 10. So limit to last. All right, let's run that again. Okay, so it gives me 10. Now if I add another one, hey, you, it doesn't fire off. So stacking on an end at or a start at kind of hamstrings your child added, and that you can't listen to the new guys. It's great for value events, but I wouldn't really use it. I wouldn't use it in this way that I just showed you. But limit to last one's awesome. You can also say limit to last 3 and load your last 3 and still be listening for additionals. Okay. But let's get into the details here of how to paginate, kind of how to work through your data using limit to last and end at. So yeah, the way you want to deal with Firebase data is you want to treat it as streams. You want to listen to the end of your stream, and then if we need to look up the stream, you query manually up the stream. So you say, I've limited the last 3 eighths right here. I want to get, let's say I want to scroll up, and I've shown you R5D4, Biggs Darklight, and Obi-Wan Kenobi, and you're scrolling up the list now, or you've clicked a button to scroll up the list. So now I wanted to limit to last 3 again, but now I want to say dot end at 8. So now I get 6, 7, and 8. Yeah. So that way you can. Oh, now I'm going to end at 6. You can sort of walk back up and paginate your way up through the list. And then when you want to go back down to the bottom again, you get rid of your end at and you get your data back from the bottom. Okay. So there's also a limit to first. So limit to first 3, 1, 2, 3. Dot start at. Let's start at 3. 3, 4, 5. So 1, 2, 3. Oh, start at 3, 3, 4, 5. Great. This works exactly like you'd think it would work. Now, here's a fun one. Let's try switching this up. What if I change the order? 3, 4, 5. 3, 4, 5. All right. Start at 3. Let's try end at 3. End at 3. 1, 2, 3. Let's change the order. 1, 2, 3. So, doesn't matter. You can call these whatever order you want, and it'll work. It's pretty straightforward. Oh, one more thing. You can also do limit to first 3 equal to 3. Whoa! Can't combine start at, end at, and limit. But you with an equal to. But you could do, if you get rid of the limit, you can just do equal to and just get 3. Okay, so you can't combine But equal to is effectively a start at and an end at tacked together. You aren't allowed to combine them yourself, but you can call .equal to and tack two together, and it'll effectively do a start at 3, end at 3. But of course, you can't do a limit. You're gonna have to get all of them. This lets you do some really rudimentary searching through Firebase, but I mean, don't rely on this for your architecture because it's not the most performant way to search your data. If you really want to search your data, you need it in Elasticsearch or Algolia or some kind of other solution where you duplicate part of your data to really search it effectively. Equal to is great for some searching, but you know, Firebase isn't built around search. It's built around collections, streams of data and pagination back up and down those streams. So don't try to use Firebase for searching. Don't try to search through Firebase. Paginate through Firebase as much as possible. And then occasionally, yeah, use an equal to, or you know, or instead of equal to 3, put end at 3. And then, you know, you still get that record, but you get some context around it. Okay. All right. So what have we covered so far? We've covered the different ways you can order by key, order by child, order by value, but don't use that very often. I've also covered end at, start at, and equal to. So the last thing to do really is just to show you that this can be done via the REST API as well. So console.log users ref dot to string. Okay, so we're just gonna log out that string. There, you see that string right there? Check this out. If I can get this string, copy this sucker to my. All right, we're gonna open up a new tab. Now this is ugly, so I'm just gonna expand that. But you can see here, permission denied. Query data users. Let's change rules so we can query data users order. Let's do .read true. Okay, so now anyone can read it. Now this is a public endpoint. Okay, so I can get my data by adding .json to any path. I mean, I can. Oh, too excited. I just downloaded it. Yeah, only users has true. All right. Anyway, so I can pull my data down that way. I can do this fun little thing here. Let's do shallow equals true. If I call shallow equals true, it'll give me that same list, but it won't give me the children. It'll just say true for the child. But I get the list. I get the object. This lets me quickly work through a bunch of keys if I want to do this manually. It's a super useful way to, say, do pagination through a really big list because I can get all these keys, and if I'm sorting by the keys, I can then sort them. And now I can build my own pages out, do my own manual pagination using this REST endpoint with shallow equals true. But shallow equals true doesn't let me do any sorting or anything because it's returning back an object, so I can't really do any queries with it. It just gives me all the children. And that's really only useful for big data sets when you're paginating. But let's see here. We can also do order by key. It'll return it to me order by key. Order by child. Let's try order by child height. I don't use this very often. I may be okay. Maybe these orders aren't very good. Let's. I don't even know. Yeah, I'm probably doing this wrong. Who knows? I don't order by child off the REST API very often at all, actually. I can do order by equals key. And end at equals And okay. I could. I'm gonna have to copy paste this sucker, unfortunately, because my order by child failed. Oh, it must be a valid key name. There we go. So I can do end at. I can of course do start at in the same way. Right. And look, the order all went away. I mean, you can't really order JSON objects anyway, so don't try, but it is nice when it returns to you in a nice ordered fashion, but just don't count on it. And I can do and limit to last equals, say 2. And I get 2. So I can build out these same queries with parameters using the REST endpoint. That's great. Not the most useful. I frankly just use REST for shallow equals true. And I've got a huge data set and I just want all the keys. I don't want to pull all the data down because maybe I got megs and megs of data. Maybe I have gigs of data and I have a lot nested under there. I just want the keys so I can sort through them and do some quick pagination. Just display a few things to my user. I will pull the keys down using the REST API. This is my primary use case for the REST API. Now you can build a whole app just using the REST API. You can do all the Firebase functions basically using the REST API. But don't recommend it. Anyway, all right. So I think that's all I needed to cover here for pulling down your data, querying your data with Firebase. So let me know in the comments if you have any questions and I will do my best to answer them. Thanks a lot for listening.